Picture this. A star out there in the Milky Way suddenly winks, not once but over and over again with no rhythm or reason. Astronomers across the globe lean in, their hearts racing. The internet runs wild with whispers of alien megastructures. Yet the truth is far more surprising. In the next few minutes, you'll join a journey through dusty rings, shattered moons and speculative Dyson spheres to uncover the real story of Tabby's star. Buckle up, because when science meets mystery, the ride gets wild. Oh, and before we dive in, make sure you subscribe, like and share this with your mates. You won't want to miss the twists that come next. To get why this blinking star matters, let's set the stage. Back in 2009, NASA launched the Kepler Space Telescope to stare at one patch of sky and catch tiny blips as planets cross their stars. The idea is simple. When a planet like Jupiter moves across its star, the star's light drops by about 1%, and you can see that dip in a light curve. Scientists wrote software to sift through the data, but computers miss things that humans find obvious. That's where the citizen scientists of the Planet Hunters project came in. One evening in 2011, a group of volunteers noticed a light curve that looked nothing like a neat planet transit. The star seemed ordinary, an F-type main sequence star about 1,500 light-years away in Cygnus, yet its brightness plummeted by 15%, then 20%, and stayed low for days at a time. People were stunned. 15% is like a skyscraper blacking out the sun. Tabitha Boyajian, an astronomer at Louisiana State University, led the investigation and lent her nickname to the mysterious object, Tabby's star. It was named KIC 8462852 in the Kepler catalogue. You can't see it with the naked eye. You need a telescope to spot its faint glow. The discovery felt like stumbling onto a story of science fiction. Planet Hunters volunteers traded messages late into the night, sharing speculation. Boyajian later said it reminded her of solving a cosmic puzzle with friends scattered across the world. Their excitement will draw you into this mystery too. After the initial buzz settled, Boyajian's team pored over the Kepler dataset. The light curve was chaotic. Instead of tidy planetary dips, it showed jagged, asymmetric drops. Some lasting days. One dip reached about 22%, another hovered around 15%. Such depths are unheard of for normal transits. It would take an object far larger than Jupiter to block that much starlight. The timing was erratic too. In May 2017, a 2% dip appeared and was playfully nicknamed Elsie after the letters LC for light curve. A few weeks later came Celeste, then Skara Brae and Angkor. Each dip had its own shape and duration, and none came at regular intervals. Amateur astronomers from Hawaii to Spain joined the chase, pointing backyard telescopes at a star barely visible to the naked eye. Boyajian said the community went mildly bananas, trying to catch each blink. To ground the story, remember what this object is. Tabby's star, officially KIC 8462852, lies in the constellation Cygnus, about 1,470 light-years from Earth. It's an F-type star with a faint red dwarf companion. At magnitude 11.7, it's invisible without optics and sits between the bright stars Deneb and Delta Cygni. In every respect, it's ordinary, except for these wild light curves. Imagine sitting on your back deck watching headlights on a distant highway. A planet transit is like a small car cutting the beam for a moment. Tabby's dips were like huge trucks lumbering past, each one shaped differently, separated by irregular gaps. Citizen scientists woke early to watch the dips. One volunteer likened it to waiting for a rare bird at the feeder. Another said it was like watching a thriller where the clues hide in the flickers. Those experiences kept the Planet Hunters engaged and made the data feel personal. By the end of Kepler's mission, there was another surprise. the star's baseline brightness seemed to be slowly fading. Historical photographic plates from as early as 1890 hinted that the star has dimmed over more than a century. This long-term fading added another layer to the mystery and set the stage for a cascade of hypotheses. When faced with a puzzle, scientists look for mundane explanations first. Tabby's star was no different. The first suspects were clouds of dust. Maybe the star was young and still surrounded by a disk of debris, like the rings around Saturn scaled up. But follow-up observations showed no excess infrared radiation, which you would expect if warm dust were absorbing light and re-radiating it. The star also lacks the strong spectral lines seen in stars still wrapped in birth cocoons. If there is dust, it must be cold and patchy, not the thick disk of a newborn. Another idea was comets. A swarm of icy bodies on eccentric orbits could produce irregular dips. Comets are small and dusty, so they'd block only a little light individually, but maybe a family of comets broken apart by a passing star could do the job. A single comet, however, blocks much less than 1% of starlight. To get 15%, you'd need thousands of comets lined up by chance, which stretches credulity. Observers also noted that the dips were achromatic. They affected blue and red light differently, which implies dust grains of specific sizes, not large opaque bodies. Some astronomers proposed that a planet was breaking apart, leaving a debris field that periodically crossed our line of sight. Others imagined a giant ringed planet with rings oscillating up and down like a spinning frisbee wobbling on a bar. Still others thought of a planet being eaten by the star, its crust peeling away like layers from an onion. Each model could explain one feature but failed to fit the full light curve. The dips were too deep, too irregular, or lacked the expected heat signature. Tabby's team took these failures in stride. One colleague likened it to investigating a bushfire. You first check if someone left a campfire burning, then if a lightning strike hit a tree. Only after ruling those out do you consider arson. The scientists also invited amateurs into the process, posting data publicly and encouraging comments. That transparency, rare in big missions, allowed people to feel part of the hunt. As hypothesis after hypothesis fell, the imagination began to roam further. With natural explanations faltering, the story took a sensational turn. In the 1960s, physicist Freeman Dyson suggested that an advanced civilization might encircle its star with a swarm of energy collectors. A so-called Dyson sphere would harvest a star's power, radiating waste heat in the infrared. The concept has since popped up in science fiction novels, fueling the hype. When the Planet Hunter's light curve hit the press, headlines screamed that we might have found an alien megastructure. The dips were deep and irregular. Could enormous panels be slowly moving into place? Astronomers were cautious. Boyajian herself said she considered the alien idea last, not first. A Dyson sphere would absorb light across all wavelengths, and the re-emitted heat would glow strongly in the infrared. Observations with the Spitzer and Swift space telescopes showed no significant infrared excess, effectively ruling out solid, opaque structures. The dips also varied by color. Blue light dimmed more than red, consistent with fine dust particles rather than giant panels. Still, the speculation captured imaginations. People on internet forums mapped out possible megastructures, comparing the dips to gaps between panels. A radio astronomy group in California pointed their antennas at Tabby's star, listening for artificial signals, but heard only cosmic static. On talk shows, astronomers were asked, tongue-in-cheek, whether we were about to meet our galactic neighbors. One researcher quipped that if aliens built a Dyson sphere, they'd have to mine entire asteroid belts, leaving other fingerprints we could detect. The cultural moment said as much about us as about the star. Humans are storytellers. We yearn for company in the cosmos and love a mystery with a science fiction flavor. In a pub in Sydney, a group of astronomy students joked about how they'd design a Dyson sphere to power an outback town. Most scientists saw the alien hypothesis as a useful thought experiment rather than a serious contender. By late 2016, the lack of infrared emission had knocked the Dyson sphere down the list of suspects. Nonetheless, the attention it garnered reminded people that the universe can still surprise us, and that sometimes the wildest theories, even when wrong, push research in new directions. While headlines trumpeted aliens, astronomers quietly collected more data. In 2017, a worldwide observing campaign was organized. Professional observatories and backyard telescopes coordinated to watch Tabby's star around the clock. They caught dips in real time and gathered spectra across different colors. These new observations confirmed that the dimming was stronger in blue light than red, a sign of fine dust scattering light. If large, opaque bodies were causing the dips, the star would dim equally across all colors. Researchers also noted that the star's overall brightness is slowly declining over decades. When you combine a long-term fade with short, deep dips, you're likely dealing with multiple processes. Some teams suggested that the star might be shedding material after consuming a planet or interacting with its companion red dwarf, releasing streams of debris. During this period, dips like Elsie, Celeste, and Skara Brae were observed again, confirming they were not one-off flukes. In 2019, another hypothesis made waves. Perhaps a rogue exomoon was torn apart. Imagine a massive moon straying too close to a planet and being shredded by tidal forces. The fragments spread out along the orbit, forming a clumpy ring. As the star spins, this patchy ring could drift in and out of our view, producing irregular dips. Dust from the shattered moon would produce the color dependence seen in the dips. The exomoon idea isn't proven, but it shows how creatively scientists approach the puzzle. The follow-up campaigns also highlighted the power of citizen science. Amateur observers, like Bruce Gary in Arizona, built small observatories to monitor the star and ended up co-authoring papers. A group of students in Sydney learned photometry to contribute their own data. These personal stories demonstrate that cutting-edge astrophysics isn't confined to billion-dollar telescopes. Curiosity, patience, and a clear sky can make a meaningful contribution. As the data poured in, it became clear that the solution would likely be messy. Dust rings, cometary debris, exomoon fragments, and intrinsic stellar variability might all play a role. That complexity reminds us that stars are dynamic systems. The more we learn, the less alien Tabby's star seems, and yet the more captivating its story becomes. Beyond its wild light curve, Tabby's star has become a lesson in how discovery works. It was spotted not by an automated pipeline, but by volunteers on a citizen science website. Their curiosity triggered a chain of research that drew in observatories around the world. In an era of machine learning, this reminds us that human pattern recognition and hunches still matter. The saga also shows how scientists handle the unknown. Dust clouds, comet swarms, planetary collisions, megastructures, shredded moons. Each idea was put forward, tested against new data, and revised. When one explanation failed, it wasn't dismissed in anger but added to our understanding. That iterative process is the heart of science. You propose, test, adjust, and keep going. The story encouraged amateurs to join in and see that science is not a list of facts, but a living, evolving conversation. Tabby's star has broadened the search for extraterrestrial intelligence as well. For decades, researchers mostly listened for radio signals. The attention on a potential Dyson sphere spurred a new field of techno-signatures, unusual patterns of light, heat or chemistry that could hint at technology. Even though the alien hypothesis faded, the concept got astronomers thinking about indirect evidence of advanced life. Perhaps most importantly, the mystery rekindled wonder. Farmers in the bush, students in city flats, and retirees with backyard telescopes joined a global hunt. They learned basic photometry, shared data online, and felt the thrill of contributing. Many said it made them feel connected to something larger than themselves. In a world of fast news, a slow unfolding puzzle like this fosters patience and curiosity. As things stand, the best explanation for Tabby's star involves a complicated mix of dust and debris rather than alien engineering. Because none of the proposed hypotheses fully explain all aspects of the light curve, scientists continue to watch the star fade and flicker, waiting for more clues. Yet the value of the journey lies in the way it brings people together and expands the horizons of inquiry. There will be other strange stars and anomalies. Thanks to this one, we'll be better prepared to ask good questions and to appreciate the mysteries that remain. So where does this leave us? After years of watching, debating, and dreaming, Tabby's star remains one of the most intriguing objects in the sky. The irregular dips, the long-term fade, and the color-dependent dimming point to dusty debris rather than alien engineering. Yet the full picture is still emerging. What started as a curious blip on a graph has evolved into a global conversation about how we explore the unknown. Whether the culprit is a disrupted moon, drifting dust, or a combination of factors, the star reminds us that even ordinary-looking suns can hold extraordinary surprises. No matter the final verdict, the idea that a star nearly 1,500 light-years away can inspire kitchen table conversations in Perth and cattle stations across the interior is itself remarkable. The search continues, and so does the excitement. In the process, the story has rekindled a sense of wonder and shown how science thrives on collaboration between professionals and amateurs, between cultures and between generations. If you enjoyed this cosmic detective story, don't let the mystery end here. Hit the subscribe button, give this video a like and share it with your mates. Leave a comment telling us what you reckon is causing Tabby's star to flicker: dust, exomoon rubble, a comet swarm, or something we haven't imagined yet. Your engagement helps the channel grow and lets us keep bringing you stories that spark curiosity and wonder. Invite a friend to watch with you, join the conversation, and keep an eye on the night sky. If you're new to the channel, consider joining our community of sky watchers. Together, we'll explore more mysteries and celebrate the joy of discovery. Cheers!